So today we are still going to be looking at factoring. But today we're going to look at equivalent factors. And the reason why I say my students don't really love this is because it's just kind of tricky. There are some pieces of it that are pretty straightforward. But there are some pieces of it that are really tricky as well. Okay, what do we think equivalent factors is going to mean? Equal what? What's equivalent mean?
Equal.
Right, they're the same value. What are factors? Right, when we multiply them together, right, they give us whatever. So we're going to be looking for different ways we can multiply pieces and get an equivalent number. So if we're looking at 60, just like when we've been factoring trinomials, 1 and 60 is equivalent to 2 and 30, which is equivalent to 3 and 20, 3 times 20, right, which is equivalent to 4 times 15, right? All of those are equivalent. They are all different ways that we can write 60. So we want to now look at when we factor a trinomial, or anything, when we factor something, what are all the different ways that we can write them? Maybe not what's factored completely, but what are all different representations of the exact same value, the exact same polynomial? So let's just start with something simple. And you're going to laugh at me when I say that this is simple, but this is a pretty simple one. Let's start with 2y squared plus 14y plus 24. Okay, so if we look at this, and we want to find equivalent factors, the first thing our brain is going to do is say, okay, let's not worry about equivalent factors right now. Let's just factor. Okay, so if we want to factor this, what is the first thing we should consider? Is there a GCF? Because that's always what we consider first. So is there a GCF in this problem?
Yes.
Yes, a GCF of 2. So there's our first piece. What do we do after we factor out the GCF? Yusuf?
Count how many terms.
Count how many terms there are. So we have 3. So now we're going to consider a trinomial. So 1 times 12 is 12.
It's a short.
This one is a trinomial shortcut. So 1 and 12. 2 and 6.
3 and 4.
3 and 4. Which set are we going to pick?
3 and 4.
3 and 4. Everything's positive, so we keep with positives. So this becomes a y plus 3.
You bring the 2 down.
And a y plus 4. And our 2 comes down in front. We have now factored this completely. Okay, but that doesn't mean we have found all of the equivalent factors. Okay, we have found some though. So equivalent factors are the sets that happen all the way along the way. So here is one representation of our original problem, right? 2 times y squared plus 7y plus 12 is equivalent to our original polynomial, right? If I distributed that 2 back out, I would get the original polynomial.
Yeah.
So that is one possible answer of what is equivalent to 2y squared plus 14y plus 24. Here is a second equivalent answer. 2 times y plus 3 times y plus 4. That's a second equivalent option. Yes, Bailey?
So I was like looking at our second option, but wouldn't our second option have to be squared altogether to get that to our first answer? Since we had to distribute twice and come down to it?
No, because when we distribute here, right, y times y will give us the y squared times
So
4y.
Okay.
Right, that will all just come back to here. These two will make this.
Yeah.
And so it takes us back. So this is still our second one, just like it is. Okay, and then my student's like, perfect, that's great. In my work, I found 2 of them. But we actually have a couple more, and you don't know it, but I sort of was getting you to think about this when we did the sticker quest. Because right in that sticker quest, we said, okay, well, what happens if I take this 2 and I distribute it into one of the binomials? I can't distribute it into both of them. Right? When I multiply something that's 3 pieces, so if I wanted to multiply 2 times 4 times 5, right? I multiply 2 of them, and then I multiply the third. I don't multiply that 2 times 4 and 2 times 5, right? Just once. So if I distribute this, this becomes a 2y plus 6 and a y plus 4. There's a third option. That's not the only way to get that set. Hey, you could get that set by not factoring out the GCF and multiplying these, but nobody wants to start factoring back over, right? It's way easier to just pass that in. But we're still not done, because what if we decided not to give that 2 to this first set,
But give it to the second
but
one.
instead we decided to give the 2 to the second set?
So that's 2y plus 8.
So then we'd have a y plus 3
And 2y plus
and a 2y plus 8. And there's a fourth option? Right, it would be okay if your binomials were reordered in a different order. Okay, yes?
Can we reduce that? Yeah, same thing,
To factor this 2 out?
yeah.
Yeah, it would take you back here.
Okay.
Because this is the factored completely form. But now we're not talking about what's factored completely, we're just talking about what equals it. Okay? And my students are like, oh, well, that's not too bad. Right, I get 4 options, that's not a whole ton of them. That seems like a pretty reasonable thing.
You're wrong.
But it's not always quite that simple. Okay, here's what I will say. If you can do this, these 4, that's good. That's pretty good. Okay, but let's look at another problem. Let's say we have something like, let's also stay pretty simple, 6y squared minus 24.
This is a small,
Oh, yeah, so special base.
but there's a GCF.
So if we look at this, what do we always think first?
GCF.
GCF. Is there a GCF?
Yeah.
Yes, what is it? 6. So 6 times y squared minus 4 is equivalent to 6y squared minus 24. No problem. Pretty good. Cruising right along. What do we do next? Special case, right? Number of terms is 2. So 2 terms will look for a special case. What number times itself gives us 4? 2. What number times itself gives us? Right number. Y. Y times y. So this factors into a y minus 2 and a y plus 2. So 6 times y minus 2 times y plus 2 is also equivalent to our original polynomial. Okay, so now we can distribute into one of the binomials. So let's say we distribute here. So 6y minus 12 and a y plus 2. That's a third option.
And then just flip it.
What else could we do?
6y plus
Right,
12.
distribute to the other one. Sorry, my brain's thinking ahead. Y minus 2 and 6y plus 12. Anyone have any other ideas?
The exponent like outside the
No, because they're not both subtraction. But yes, on some of them we could. That would be something we should consider. Yes, Jack?
the GCF of 6 and 12.
So if we do that, that will take us back up here. Yes, Emma? If we multiplied them both together, that would take us back up here. Yusuf?
Can you distribute the y minus 2 into the 6y plus?
If we do that, that will take us back up here. Would we agree that 6 is really 2 times 3?
Yeah.
Oh dear, right? So now what if I leave the 2 out in front and I only distribute the 3? So what if I say
Really like 6 of them.
2 times 3y minus 6 times y plus 2? And all of you just went, oh dear.
Wait, what if the number out front is 24 and it has like more?
Oh yes, what if the number outside is 24? Oh dear. Oh dear. Oh dear.
So you just have like a bunch of them?
Oh yes, you sure do. What if instead of, I mean obviously right, I could also distribute the 3 to this one. But what if, let's just consider another option. What if I distribute the 2 to one of them
And keep the 3.
and the 3 to the other one? So then I have a 2y minus 4 and a 3y plus 6.
What if you did the 3 on the first one and the 2 on
Right, I could do the 3 on the first one and the 2 on the second one. I could only distribute the 3 to both of them, right?
And then like the 2.
And we haven't even got to a GCF out in front of being 24, where we have options of 1, 2, 3, 4, 6, 8. 24. Oh, geez. Right? Whoa, there's a lot. So, here's what I'm going to say.
Me.
A, I don't think that there will ever be a situation that says list every single possible equivalent factor that there are. That's not going to be a requirement. Okay? Instead, what I think you would have is something that says list 4 equivalent factors. You have to come up with 4. Or maybe something like this. Oh, sorry.
Yeah, I'm not about to write that one diagramist.
Alright.
And realistically, guys, you probably don't even need to write this last one down in your notes. I'll leave that up to you. And I'm going to keep it pretty simple in hopes that we get the idea. You might see something like this. This would be more realistic. That would say, find all of the equivalent options. Because what is more realistic in the real world isn't that you're writing down every option, but instead what's more realistic that if someone's work didn't look exactly like yours, you should be able to recognize, oh, but wait, we're really talking about the same thing. Right? How often have some of you heard that happen in math class where you're arguing about something with a classmate or a peer, right? And you're going, wait, no, that's not what you do this. And then the teacher goes, you're both talking about the same thing. Right? It maybe looks slightly different, but you're realistically talking about the same thing. So could we go through here and could we decide which of these are actually equivalent to 8x plus 16? So there's a couple ways that you could do this. A, you could multiply all of these out.
No.
Okay? This one is a very simple one, so multiplying them all out really isn't that much work. But if it's any other type of longer factoring, especially with an exponent of 2, that starts to get more complex. Yes, Bailey?
We can also just use process of elimination.
Not always, okay? Yes, you might be able to eliminate some. Okay, the other option is that then you could start factoring. So let's factor 8x plus 16. What would we do first?
GCF.
GCF. There's no special case, there's nothing else. I picked a simple one on purpose. So what do we know up here could be an answer? A. So let's start going down the list. We factored it completely. Most likely this would be more work, but I picked a simple one. We factored it completely. So B, could B be an answer?
No.
No. Right? It has one of the factors, right? X plus 2 is a factor, but it's not equivalent because it's missing the 8. So no.
C is not.
C, is C an option?
No, because.
No, this is not a special case, so that's not an option.
And that also come out to.
Is D an option?
Yes.
Why is D an option?
Because
multiply it back out.
Okay, so option 1 was that we could multiply it out and see if it's equivalent. How about option 2? Can we tell where this comes from based on this up here?
Yeah.
Where does it come from?
Wait.
What can 8 be split into?
4 and
2
2.
times 4. Right, so the 4 is outside. What happened with the 2? It got distributed in. So this could be an answer.
The other one could too.
Can E be an answer?
Yeah.
Yes, where did E come from?
The same, but they. Yeah.
Same process, but the 2 stayed outside and the 4 was distributed.
F cannot be an answer.
Can F be an answer?
No.
No, right. right? Because a 4 stayed outside and a 4 was kind of sort of distributed incorrectly. That doesn't work.
That's what I was saying when I was gonna sell on